in this lecture we'll be looking at what I tag arithmetic operations. In MATLAB there are built-in constants that we can find handy and carry out our computation. For example, we have what we call pi that we know to be 3.142 in MATLAB. To access pi, which is 3.142 generally, we use pi. When we type pi, we are able to access that constant. For example, we can get a variable and equate it to equals to pi. So it returns that value to us. Before we move on, one thing we can take note of is that MATLAB has returned 4 decimal places to us. However, computationally, MATLAB stores variables in double precision, which means about 15 digits. A variable can have about 15 digits, even though by default it's going to show 4 decimal places. So here is a table showing some of the built-in constants that are in MATLAB. We have the imaginary unit, sometimes I, sometimes j, that we know that it equals to minus root of minus 1. We also have the infinity and the NaN, which refers to not a number. So from this constant we could get derivatives. For example, we can create a variable x which is equal to pi over 2. So when we need to get pi, like I said, we enter pi. So in this case, pi divided by 2, and we have that result. Likewise, we also have built-in functions, a lot of built-in functions that are in MATLAB that we can find handy. If you want to have a glance at the list of elementary functions that people normally use interface with in their computation, we can call up lfunc as a function. When we type help lfunc is going to give us a list of the elementary functions that are built in MATLAB. So they are called built-ins generally. So if as I've typed help lfunc now, I'm expecting to get a list of all of the elementary functions that are available in MATLAB. So let's give it a moment for it to process the result. Okay, here are some of the list of the elementary functions. It has been sectionalized. We have the trigonometric section, we have the exponential section, we have the complex function, we have the rounding and remainder section. So to get deeper understanding of each of these functions, we could type document function, or document the name of the function that we are looking at, and that will give us comprehensive explanation about how that function works, what it does, the input it takes, and all of that. Okay. So we can also find the list of the special functions that are available in MATLAB by typing help spec fun. So let's give it a moment for it to process the result for us. So these are the special functions that are currently available in MATLAB. Now this information can be useful when you progress in your engineering journey. You know what is available in MATLAB, and you know where you can find more details about it, and it will make use of them. Okay, so for most of the functions in MATLAB, what you need to do is just similar to how you use the functions in your mathematics. You get the function, you open a parenthesis and supply the argument that you want to put in it. Now, for example, we can say sine of a value. Now, the value that is going to be input into it is going to be an angle. An angle in generally can have a unit of degree, can have a unit of radian. If, for example, you call sine x in MATLAB believes that if you are calling sine, if you are using sine as a function, the angle that is being passed into the parentheses is measured in radian. If you are using cos also, the angle that is being passed into the parentheses is expected to be in radian. The same thing with tan. So if the value of your angle is not in radian, perhaps it's in degree, that means if you are going to be using something like sine, cos or tan in MATLAB, you need to convert that degree into radian so that MATLAB processes exactly what it needs to process for you and you get the accurate result. So let's say, for example, we have a variable b that is equal to sine 5. So after typing sine, sin, the next thing is to open a parenthesis and supply the argument. In this case, we want the argument to be minus 5 radian. So we just put minus 5, we press enter and it returns the value for us. So when you call a function, you open a parenthesis and supply the argument that it needs. But you must understand how does MATLAB interpret this. Like I've said, if you are using sine as a function, it believes that the argument you are supplying is in radian. Okay, so this is just an abridged version of some of the functions that are available in MATLAB. If you want to get the cosine of an angle, you use cos s. If you want to get the sine of an angle, you use sine x. If you want to get the tangent, you use tan x. The same thing, you can have the arc cosine, which is a cos into x. X in this case is the argument you are providing. We can get arc sine using a sine x. We can get arc tangent using a tan x. To get exponential, you can use exp, open the bracket and supply the argument. To get the square root, you can say sqrt, then you pass in the value that you are looking at to get the square root. Then for natural logarithm that we call ln, you can simply use log x. And for the common logarithm, which is to base 10, you can say log 10 into x. To return a value as positive value, irrespective of if it was negative or positive before, you can use ABSS, which is absolute value of x. To get the maximum of a value, you can use maximum x. To get the minimum value, you can use minimum x. For rounding issues, you can use something like ceil x, floor x, round x. And to get something like the remainder after a division, you can use rem x. So for phase angle computation, you can use angle x, and for conjugate computation, you can use conj x. You can find more details on that in the documentation of MATLAB. Okay, so let's apply square root function to get the square root of minus 9, and let's see what happens. So to get square root, we just said the function is sqrt. We open a parenthesis and supply the argument. In this case is minus 9, and this is the outcome. So we notice that the real part is 0 and the imaginary part that is returned to us has I, and I, like we have said earlier, is a representation of imaginary number which has a value of root -1. So it's a constant, a built-in constant in MATLAB. Okay, with MATLAB we can have control on how our results are displayed. By default, we have said that MATLAB displays 4 decimal digits, but it can display more or less than that, and that will depend on the configuration we supply to MATLAB. On the screen are some of the approaches to control the display of results, the precision of the result that we get. For example, we can use the format command, we can use the round function, we can use the num to string function, we can use the fprintf function to determine how the results are presented. So when MATLAB displays 4 decimal digits, it means that it operates on format short by default. So when you are on format short mode, the decimal places that will be returned will be 4. But if you change to format long, then we are going to have up to 15 decimal places, which is also known as double precision. Then we can have scientific notation of the result, and if we want the scientific notation to have about 4 decimal places, we can use something like format short E. We can also have the format long E that allows us to have the result displayed in scientific notation, however, with 15 decimal places, up to 15 decimal places. There are more other format commands that can be explored, and we can have deeper knowledge of these by typing doc format, and that will give us details of things that are possible using the format command. So we've seen that so far the results that we have obtained are in 4 decimal places. So let us switch to format long and get the value of x. Let's see how it looks like. So we say format long. Okay, so now to get the value of x, we just type x followed by enter. So now you see that it has displayed more than 4 digits for us for x. So one limitation of the format command is that it is global, the effect is global. So every other result it brings, now that I've changed to format long, we have 15 decimal places. So if that is what I want, that all other results that I compute henceforth should be 15 decimal places, then it's fine. But if that is not my intention, then format command may not be appropriate, because whatsoever format mode you are in is going to affect every other result you get. So if I want to move away from the format long back to the default, then I have to type format short to return to what it was. So now that I'm in the format short mode, if I get the value of x again, it's going to be in 4 decimal places like it was before. So let me try format long E and format short E and get the value of x to properly suitate a few examples. So let's get to the mode of format long E, and let's get the value of x. Okay, so the E here is the scientific notation. It's a scientific notation. And let's move to the format short e. And get the value of x. So there's still that e there, denoting that this is scientific notation. However, this is raised to power 0 at this time. Okay, so let me return to the format short, which is the default mode. Okay, so we said another way of controlling the appearance of our result is to use the round function. With the round function, we can specify how many digits we want our result to be rounded to, the number of digits after the decimal place that we want it to be. So how does it work? We call the function round, open the parentheses. The first thing we supply as an argument is the variable that we want to round, followed by the number of digits that we actually want after the decimal place. These two arguments are separated by a comma. So let's say, for example, x variable that we have created, we want to round it to 2 decimal places. So, and store it in what we called r_x in this case. So this is a syntax to do that. So we call the function round, put in the variable, in this case which is x, followed by the number of digits we are looking at. The two are separated by a comma. So, okay, let me remove the semicolon after so that we could see the results being displayed. So now we have our r_x equals to 1.57. Also, we can use the num to string to control the appearance of a floating number. Num to string can be advisable when you are writing into a file and you need to convert from numeric version to string, so it's applicable, and also it gives you the advantage of controlling the precision of the result. So how does the num to string work? You call the function num to string, open the bracket, supply the variable followed by the format in which you want the variable to happen. So in this command that we have here, so the idea is to convert our x value into a string, and we store it into a variable str. So once we convert x and store it into a variable str, one thing happens. Str, which is the new variable we have created, will behave like a string, not like a numeral. So you can't do any computation on that variable str. Now, what do we supply to convert x to a string that we store in str in this case is that we call the function num to string, and we supply that variable x followed by the specifier. The specifier in this case is float. F here is saying we are looking at a floating number, and before saying float, there is that percentage that is telling us that this is a specifier. Then the .3 is saying that we want to have 3 decimal places. The .3 is saying 3 decimal places is what we are looking at. So let's press enter and see what happens to the value of str that we would create. So the value returned to us is 1.571. which is as expected. The next approach is the fprintf function. The fprintf function is particularly of importance when you want to write into a file. Then it also gives us the privilege of using different specifiers, format specifier. Aside from handling numerals, you could handle strings also using the fprintf function. So what's the format? The format is that you call the fprintf function, you open the parentheses, then you put in a string that contains the format specifier or format specifiers if you have more than one format that you are looking to pass into it. Then after that, okay, even in specifying the format specifier, you need to put that in quotation to show that this is string. And after you are done with that, you follow it with a comma and you list all of the variables that you have created a format specifier for, and those are the variables you want to appear in a particular way. Okay, so these are examples of some of the format specifiers that are available. When you see %g, it's a format specifier or a placeholder for integer values. When you see %f, it's a placeholder or format specifier for floating point values, numbers that have decimal places after them. When you see something like %.nf, it's similar to the example we just finished. It's saying that this, we are handling a floating point values that has n number of digits. N there is specifying the number of digits after the decimal. Then if you say %e, you are saying that express this value in scientific notation. %s is saying the variable I will pass in shortly is going to be string. If you have /n, \n, you are saying after this you move to the next line. So let's see an example of how this works. Let's say we have a variable x which is equal to 5.6789, and we want to print the value using fprintf function. So the first thing is to create that variable. Let it be available to MATLAB. So we have that. If we are using the fprint function, the syntax should look somewhat like this. The fprintf is the function, the parentheses is opened, and the first part is the string part. So the string part is represented by the quotation. So this is what we want to type. The value of x is. Now x is a variable that we want to configure the number of digits that is after the decimal place. So in that wise, you give a placeholder to hold that variable. So you put a placeholder. In this case, we are saying that x should have 2 decimal places. So percentage is the way to start a placeholder or a specifier. In this case, .2n is saying 2 decimal places, and f is saying what we are passing in is going to be a floating number. Then by /n, we are saying that the command icon should now move down after typing all of this. Now after that, since we have created a placeholder for a variable, we include a comma and supply that particular variable that we want to pass into the placeholder. So let me press enter to see what the outcome looks like. So we have the text that says the value of x is Now in place of the placeholder, we now have the value to the number of decimal places that we have specified. So we have the value of x is 5.68. Okay, so it's not only one variable that you can pass in. You can pass in more than one variable, which means that you can create more than one placeholder. In fact, you can combine, you can pass in as many different specifier into the fprintf function, and that's one of the strengths of using the fprintf function. So let's say we want to print the value of a and the value of b. In this case, a is an integer and b is a floating number that we want it to be 3 decimal places. We can also do that. We put the placeholder at the appropriate places inside the string part of the fprintf function. After the string part of the fprintf function, then we pass in the variables in the same order that their specifier appears in the string part of the fprintf function. So let's try this and see what the outcome looks like. We want to create a variable a which is equal to 3. We create a variable b that is equal to 7.1234. Now we want to print a equals to that value and b equals to that value, but in this case now to 3 decimal places. So to represent digits, we said the format specifier is %d. So when I say a equals to %d, MATLAB already knows that an integer is going to be passed in at that point. And b equals to %.3f, so it knows that it's going to be handling a numeric value that will involve decimal places, and it should print it out as 3 decimal places. So the first part, the first placeholder is %d. So that means what I supply first is going to be an integer. Then the next part is going to be the part that has to do with the 0.3f. Okay, so if I press enter, then I'll see it printed. A equals to 3 and b equals to 7.123. So the placeholder has been dynamically filled up by the variables that we passed into it. So our variable can be a string also, and fprintf can be used to print it out. So in this case, let's create a string variable called name, and the value is going to be MATLAB lecture. Okay, so we have that. So let's print that using fprintf. So with fprintf, we want to say welcome to MATLAB lecture with exclamation mark. Okay, so instead of putting MATLAB lecture, because it could be anything, that variable could change, so we just put a placeholder that is appropriate for it. We include a placeholder that is appropriate for it. In this case, it's going to be string, which is denoted by %s. So when I press enter after this function fprintf, then I expect to see something like welcome to MATLAB lecture. Then this \n is saying that once you print that, move to the next line. So we have that. Welcome to MATLAB lecture. So in trying to format the output of our result, if we use the format command, it's going to affect the precision globally. Every result that you generate is going to be affected by the format mode that you have selected. If you use the round function, it's going to round the number of digits explicitly to the number that you have given to it. If you use the num to string, it's going to convert numbers to strings with this precision that you have provided to it. With the fprintf command, you can have control over how the output looks like, and it could include numerals and text. You could mix them together, and even if it's numerals, you can have different types of presentation of the numerals. Okay, now we move to what we tag hierarchy of arithmetic operation. When MATLAB works to compute, it does it the same way we have been taught at the elementary level on how computations are to be done, following the BODMAS rule. The BODMAS rule, B here means bracket, and we have called it here parentheses. O means order, otherwise known as exponentials. The next thing is D and M. D means division, M means multiplication. Then we have addition and subtraction. So when MATLAB wants to compute, it looks at the precedence of the operators that are involved in the command. So if there is anything like parentheses, otherwise known as bracket, it computes that first. So if there are several parentheses enclosed in each other, it's going to start the computation from the inner parentheses and move outward. Then after doing the computation for the parentheses, the next thing that is of higher precedence is the exponential, otherwise known as order. So if there are many exponential terms there, it's going to work from left to right. So it treats the exponential term on the left before it treats the one on the right. So after being done with the exponential terms, it looks for the multiplication and division operators. Division and multiplication have the same precedence in computation in mathematics and in MATLAB. So if there are several of these in a command, it works from the left to the right. And also addition and subtraction have the same precedence, which follows that of the multiplication and addition. So if we have several of addition and subtraction in a command, then it's going to process it from the left to the right. So we should be aware of this so that we can actually give a command to MATLAB exactly the way we mean it, exactly the way it's going to interpret it and generate result, so that there are no conflictions in what we expect and in the way MATLAB interprets. So let's say, for example, looking at the example on the board, we have 1 plus 2 times 3. So MATLAB is going to compute the 2 times 3 first, because multiplication is of higher precedence than addition. So once it gets that value, then it computes the 1 plus the value that it has generated by computing 2 times 3. So we expect that the solution is going to be 7. So let's create a variable that is called n and is equal to 1 plus 2 times 3. So the symbol for addition is the plus that we are used to. The symbol for multiplication is the asterisk. So MATLAB has given us 7. Now if we introduce parentheses, let's say what is on our mind is that we want 1 plus 2 to be added first before the multiplication part takes place. That means we should introduce a parenthesis because it's going to change the order at which things happens, because we know that bracket or parentheses have higher precedence than multiplication. So that means what is in the parentheses will get computed first before it moves to the multiplication operator. So if we introduce the multiplication operator to enclose 1 plus 2, then the outcome is going to be different because the order has been changed. So let's say this is a variable m. So if we try that, then okay, so MATLAB does not understand cross, so we need to put the right operator. The right operator in this case is asterisk. So we fetch the old command and go to where the error is and replace it with asterisk. So now it should give us the result. So we get 9 as a result. So we should learn how MATLAB speaks, how MATLAB interprets, so that the working together of MATLAB and the user can be smooth and as expected. So here is another example on the screen that says, if you read it out, 1 over 2 plus 3 square plus 4 over 5 times 6 over 7. Okay, over 1 over means 1 divided by. Okay, now the appropriate way to handle this is the 2 plus 3, they form the divisor for 1. So the right way to do this is to include 2 plus 3 raised to power 2 in a parenthesis, to enclose it in a parenthesis, even though that parenthesis is not visible, is not part of what was written. But the ideal way to do that is to enclose 2 plus 3 raised to power 2 inside a parenthesis, so that MATLAB can know that that 2 item forms the divisor for 1, so that you could compute that, get the value as an entity and use it to divide 1, even though the question does not include that parenthesis. But that's the way to put it to MATLAB, so that MATLAB understand exactly what you want it to do. Okay, so every other thing is the way it is, plus 4 over 5 times 6 over 7. That's fine. But if you like, you can include some parentheses at some point, but for this case it actually does not matter. So let me remove them and let's fetch the value. So it returns that if by error we did not include the parentheses, just say because we didn't see it or we are not aware that it has to be like that, and we just say 1 over 2 plus 3 raised to power 2 plus 4 over 5 times 6 over 7, just we have read it, the answer will be different. So let's try that. So we get a different answer. So the take home here is that we should know exactly what we want and put it to MATLAB the way it will interpret it exactly the way we want it, so that we can get the right output. Okay, so we have looked into built-in functions, built-in constants, hierarchy of operations in MATLAB. So let's apply it into a problem. Now there is this person that is modeling pressure and temperature behavior in a gas reactor, and the person believes that pressure is equal to nRT over V plus 2 sine pi t minus exponent minus t over 10. So here we are asked to calculate pressure at a particular temperature, which is 300 Kelvin, n, which is the number of moles, is 2, and the volume is 10, which is represented by V, and we have to report the result in 4 decimal places. So what we are trying to look at is using the basic operators in MATLAB, the multiplication, the addition, the division, and also to look at using functions, built-in functions. Then we'll also have the built-in constant there. So that is what we are looking at with this question. So the first thing we should do is, in solving this problem, is to state the data that we are given. So R is a constant, the value is 8.314 joule per mole Kelvin, which is consistent with the units that we are given for other things. And also we are given the volume to be 10 and the unit is in liters. We are given temperature, which is 300 Kelvin, and we are given the number of moles to be 2. So by the side of the given variables that we have declared are comments to help anyone that is running through the code to understand what exactly is happening. So to give comment, we start with percentage and write whatsoever we want to write. So now, beside each of the variable, we have after we have supplied the value and ended the statement with a semicolon, then we pass in the comment beside each. So after we have set up the given variables, the next thing is to do our computation. So all of those nRT over V. So we know that n is multiplying r is multiplying t, and to say that there is multiplication, what we just need to introduce is the asterisk sign. Then the over, we introduce the forward slash for that. The plus sign is still the same thing. So between 2 and sign, we introduce an asterisk sign. Then for sign function itself, we open a parenthesis and we supply the values. The first value is a built-in constant pi, and how do we get that? We type pi multiplied by temperature, and in this case it's T. We have created the variable T. Then the next thing is to move to the minus. Minus is still minus that we are used to. Then exponential. To get exponential, we have seen on the list of functions just before now that exponential is represented by exp. We open the parentheses and we supply the argument. So the argument here is minus t slash 10. Then we close the parentheses and we get the answer we are looking for. So that's the process. So let me use script for this part of the problem. Okay, let me adjust my layout. Okay, I think this is better now. So we said the first thing to do is to supply the given data. So these are the given data with the comments showing the units of each of the variable that we are given. Then the next part is to set up the equation as we have been given for pressure and as I've just explained. So we have that. Then the next thing is to present our result in 4 decimal places. So we'll be using the fprintf function for that. So this part that has been included from line 10 to 11 is the part where we configure the precision of the result. So inside the string part of fprintf function, we have a placeholder at the appropriate place telling it that we want the result to be presented in 4 decimal places. Then after we are done with that, we supply the variable that is going to fill in the place of the placeholder we have just created. So we can run the code and see what the outcome is. Okay, so let's run. So let's give it a name. So let's leave it at that. Okay, and expect our result. Alright, so this is the result here. The pressure P is 4.98.8400. So we have 4 decimal places as we have requested. So you can try your hands using other values for the variables. You can use T equals to 350 Kelvin, V equals to 12 Kelvin. Just try your hand on it and be sure you understand what each part of the code does. Okay, like I said in my introductory class, when you have a problem, engineering problem to solve, the first thing is to understand the problem. And one of the things that will aid your understanding of what is actually happening is to have a pictorial representation of what is happening. In the pictorial representation, you put the given values or the variables at the appropriate places. Then you figure out what's not known. You figure out what is the relationship with some of the variables. Then after that, when you understand what process is taking place, you know the equation that is applicable to the process, and with your understanding you begin to solve. And in solving, when you have set up the necessary equation, when you have interpreted correctly, you supply that to MATLAB so that it could process it further for you. So we have a simple question here which I believe you can relate with. It's about a triangle that has angle capital A, B and C. So we know triangles have 3 angles, and we expect that the sum of the angles of the 3 angles should give us 180 degrees. So those are the facts that you will know. So for every problem, every unique problem, there are some things you should know, that this is what obtains here. So we know that for a triangle, the sum of the 3 angles is 180. So you are given the value of angle A, you are given the value of angle B. So that said, that means you can determine what angle C is, since you know that the sum of the 3 angles should equal 180. Then you are told that the side that is facing angle A is 10 units, and you are expected to find the side that faces angle B. Using the sine rule, you are expected to find the side that faces angle C using cosine rule. So they've told you the rules to use. You are not the one determining that at this point, even though you should be able to determine that. So now that I've told you we are using sine rule for finding side B, we are using cosine rule for finding side C. So the next thing is now up to you to set up the sine rule and set up the cosine rule. So the sine rule is going to look like this. Side A divided by sine of angle A equals to side B divided by sine of angle B, which is equal to sine C divided by sine of angle C. Then we have the cosine formula that says side C squared is equal to side A squared plus side B squared minus 2AB cos angle C. So we had said something earlier that when you use the function sine, cos, tan, that MATLAB believes that the argument that you are supplying is an angle that has radian as the unit. Okay, now the value that you've been given, you should know that you have been given the angles in degree. So in trying to use sine as the function, you should remember that the angles should be converted from degree to radian. So now that we have the sine rule set up, one thing we need to do is to make b the subject of the formula. In making b the subject of the formula, we arrive at b equals to a multiplied by sine of angle b divided by sine of angle a. So that is straightforward enough to do in MATLAB. What we just need to do is, having supplied the values that we are given, we remember to convert the degree to radian if we'll be using sine as the function to call. So let's solve for the second part to get our c. Since the cosine rule says c squared is equal to a squared plus b squared minus 2ab cos angle c, we know we can determine our angle c in degree by adding angle A and angle B together and subtracting it from 180 degrees. So that will give us the angle C in degree. But since we are using cosine, so we need to remember to convert that angle that is now in degree to radian so that this can be effective. In addition to that, to get the value of C, then that means we need to square root everything that is on the right hand side of the cosine rule. So that being said, every other thing to do is straightforward. So let me clear my workspace and also clear the window command. Okay, so let me clear the script I have here. We are done with the first major example here. So now, like I said, we need to declare the variables that are given. We are given the angle A, angle B, and side A. Angle A in degree. So that's why I have called it A underscore degree underscore deg to indicate that we are saying this is in degree. Because later we get the angle in radian. So to differentiate, we have A deg, we have A rad. Likewise, B and C. So the given data is our angle A and B in degree, and the side, which is 10 units. So there is the comment beside it that is explaining what that variable is, which is angle A in degrees, angle B in degrees, and we have side A, which is a given value. Okay, so now having declared the variables, the next thing is that we understand that to use the sine function, we need to convert that degree to radian. So the next step is ideally to convert this to radian. So we have this. So to convert degree to radian, there is a function called deg to rad. So this converts a value in degree to radian. So since the function, you open a parenthesis and supply the function, the argument you want to convert. So in this case, the argument for the first one is A in degree. That is the value you want to convert to radian. Then for B, you want to convert the B in degree to radian. So once you have done the conversion, then you fetch the sine rule where you have made B the subject, and you supply everything that needs to be supplied. So we arrived at B is equal to A times sine B. Now B we are calling here is B in radian because sine works with radian, and divided by sine A. A that is inside the parenthesis of sine is also in radian because sine works with radian. So that part is going to solve for B for us. So we move to the part that is going to solve for C. So we already said that to find angle C in degree, we subtract the sum of A and B from 180 degree. Okay, so that gives us the value of C in degrees. So that's why we have this part. This part is to generate the value of C in degree, but we can't use degree straight away since we'll be calling cos as the function. So we need to convert that to radian. So it moves us to the next step, which is to convert C in degree to radian. So after the conversion, then we can now find the value of C, which is going to be the square root of side A squared plus side B squared minus 2 multiplied by side A multiplied by side B cos C in radian. So this line solves that. So the next step is to display our result, to present our result in the precision that we want. So this time around, we want the precision to be 2 decimal places for everything we have calculated. The question requests for us to get side B to get side C, but we have also included the angles in radian, since we are given the angles in degree before. So we are also showing the result of the angles in radian. So, and we want all of them to be displayed in 2 decimal places. So this part of the script is going to handle that. So for the first one, we are calling fprintf so that we could print the result, and what we want to say is that side B equals to a value. So that value is our variable B, and we want that variable B to be printed in 2 decimal places. So that's a floating number, and we denote that by percentage F. The dot 2 is saying that, okay, this floating number should have 2 decimal places. After that, we have, so it reads side B equals to that value, units. Then the window, the command icon moves to the next line. It moves to the next line. And beside that, we are passing in the variable, which is B, that we want to configure to 2 decimal places. So this same explanation goes for other variables that we are trying to print on the screen. So now that being done, we can run the script and see what the result looks like. So that's the result on the window command as we expect. So all of the placeholders have been dynamically filled up with the variable that we passed in after the string part of the fprintf function. So here are other variables that you can try your hand on to practice the sine rule and the cosine rule. So the take home here is, when you are given a problem, you can represent it pictorially, see what is actually going on there, see the known variables, put them close to where they are supposed to appear in the diagram, and know what the unknowns are, know the equations that apply, make necessary inference. Like we said that, okay, we know that the sum of the 3 angles in a triangle is 180. If we know 2, then we can get the third one. So you make the necessary inferences, you get the equations set up to solve for the unknowns. When you get it set up for the unknowns, you know what each means to MATLAB. Like we said, when you say sine or cos to MATLAB, it actually believes that what you are passing in is in radian. So you have to get that right, so that if you had your value in other units, you need to do the necessary conversion so that you and MATLAB, you are actually speaking the same language. Then you know how the operators work. You know the hierarchy in which things are done already. You know some of the functions that are available that you could call and how they work. some of the constants that are available built in MATLAB that you could call. So once that is set up, then you can expect that MATLAB will give you the outcome that you expect. So you can try your hands on this question also to reinforce the learning. Okay, before the class end, instead of using sign, we could have used another approach. So let me delete this part that prints the results, okay, and let me make some adjustment. Now if we actually want to use the values of the angles that we are given directly, which were in degree, what we could have used was, we could have used signed and cost, COSD, SIND. So if you use that function instead, MATLAB is going to understand that the argument that is going to be passed into that function are measured in degree. So we would need to convert from degree to rad. Okay, so let's remove the part that does that conversion and replace sign with signed and cost with cost, and let's see what the outcome is going to be like. Okay, so this is what we have been given, so we don't want this part anymore. But before I move on that, so we said we use deg to rad to convert from degree to rad. Vice versa, we can use rad to deg to convert from radian to degree if we need that. Okay, so back to what we are on. So let's remove the part that does the conversion and change this part to DEG. Okay, and also this part to DEG, so that we are working with degree. And remember to say this is signed, so that it understands that what we have passed into it is actually measured in degree. Okay, so this part that's converting C to rad, we don't want it anymore. And here we want this to be deg. Okay, and we remember to change this to D. Cost. Okay, so I hope we have made all necessary changes. Yeah, I think there is no oversight. I think we have made the changes we need to make. So let me clear the terminal of what we had before, the command window and the workspace. Let me clear it. So let's run this. So the result is as we expected, So now what I'm saying here is that if the argument has to be in degree, then you will have to use SIND and COSD in the appropriate places, rather than using sine and cos. If you are using sine and cos, it means that you are supplying, the argument you are supplying is measured in radian. So we continue from here another time. Thank you.